Okay, today we will look at this problem trapping rainwater. It is now a very famous problem. It is also hard marked, but once you know this problem and know how to solve it, obviously it will become easy. It is quite easy to code and quite easy to understand also. So after you spend time on this problem, you will find that what this question asks is pretty simple. It asks that what can be the means what will be the volume of water uh, which tower-like structure can store. So if you pour water from the top, what will be the amount of water which will be collected? So heights of the towers are given, and from that you have to calculate the answer. So let's say you are standing at this point at 0. You know, for this point, let's say for this width, how much volume of water can be stored? It will be this into this, that is breadth, this breadth into height. Now, we know that width of this column, it's 1. But how do we know this length? So if you think about it, its length is just the minimum of leftmost highest point and rightmost highest point. So leftmost highest point is this, and rightmost highest point is this. And if you take the minimum of that and multiply it with the width, you will get the required volume which will be stored here. Now let's look at this point. Point number 1 means point this, which has height 1. So again we will look at the maximum height towards the left of this, up to the left of this column. So this is this, and maximum height to the right, which will again be this. So you will again calculate the minimum of these two, which will come out to be this, which is 2. Then you multiply 2 into 1, and then you have to subtract the height of this column also to get the amount of water. So what we get is maximum of max left, sorry, minimum of max left, max right at ith index, and then subtract it from height I to get the amount of water at that point. And then we can sum all this to get our answer. Now how we will calculate the highest point to the left? That is quite simple. It's similar to prefix max. So means you kind of take maximum to the left of all to get the answer at that point, and similarly take the maximum from the right to get the maximum for that point, which is the maximum of all the points which are right to the point. So let's look at the code. Uh, First, let's create a variable n which will store the number of heights which we have. Now let's create some variables, namely left and right. This will also be of same dimension, which is n. As discussed, this will contain the maximum height up till that point towards left and right respectively. So let's create a variable max. Now what this variable will store is the maximum element till that point. We are initializing it with the first element for the left traversal. So let's first traverse from left to right for maximum height towards the left. So how do we calculate this max? It will be the maximum of max underscore and height till that point, and left I will store the max. Similarly, we can do this for right traversal. We will start from n minus 1, go up till 0, and decreasing in every step. Also, keep in mind that we have to reinitialize max to the last element. Okay, and also change here this to right. Seems fine. Now let's create the variable sum, which will store our final answer. And finally, traverse one last time through all the array. Now, as discussed, what will be the sum? Sum will be the minimum of left I, right I, minus the height of the respective index. And then we can safely return the sum. Let's check the code. Seems fine. Let's try and run it. It got accepted. Let's check on all cases. Yes, it got accepted. Thanks for watching.